Good afternoon and welcome back to the Fastly YouTube channel for the 10th installment of Fastly Developers Live. Now, first of all, I want to apologize if you were ready to watch the stream just a moment ago, as we accidentally went live a bit early, and you would have heard Andrew and I chatting for a while. But thanks for sticking around. Hopefully you've managed to make your way to this stream, where we're going to be showing off some more developer goodness. Now, it's been a hot minute since we last did that, but today I am really excited to get back into it as we show off an application that I'm very fond of, which is Fastly Fiddle. Now, helping with me with that today, I have developer experience guru and the original creator of Fastly Fiddle, Andrew Betts. Welcome to the show, Andrew.
Hi, Kailan.
So let's go ahead and get straight into it. Do you want to talk about what Fiddle is, Andrew, and what we're going to be doing with it today?
Yeah, well, let's first of all look at my browser and see what it actually looks like. So if you go to fiddle.fastly.dev, you get something that looks like this, and you can browse fiddles that you've created or recently executed, or you can just hit this button and create a new one. And what Fiddle is a little tool that allows you to write code that you can run in a Fastly service, and you can also create all of the resources around it. So things like origins, which you can define up here. And then you can also create template requests. So examples of requests that might be submitted to your service by end users. And then you can run those requests and see what would happen if that service was running on Fastly with that code. I wrote this as a hackathon project about 5-6 years ago, and it's become really useful for a whole bunch of different things. So first of all, we use it a lot to communicate code to customers, both when customers submit support tickets and we need to say, here's a bit of code that is useful to fix this problem. It's helpful to send that code to them in a Fiddle so they can just press run and see that working straight away. We also have a lot of code examples on the Developer Hub, which are all embedded using Fiddle, so you can run them directly in the documentation. I'm really proud of that. I think it's gives people a lot of confidence to go to documentation and be like, yeah, that code actually works because I can see it working right there. Very much inspired by MDN, actually, because you can run all the JavaScript examples in their documentation, which is fantastic. We also have people who go the other way, who send problems to us, to our support team using Fiddle, like they use it to make reduced test cases of their problems, or they will just use Fiddle to kick the tires to understand what Fastly can do, or to see whether a particular technique or pattern would work if they were to add it to their Fastly service. So a whole bunch of different things that you can do using Fiddle.
Fantastic. Okay, so do you want to quickly cover the exercises that we're going to be showing today?
Oh yeah, right. Okay, so we've picked 4 things that we can do that will cover a bunch of use cases, which are interesting things to do to do using Fastly anyway, but they're also useful kind of scaffolds on which we can build a kind of workshop around Fiddle features. Even if you're like a regular user of Fiddle, the idea here is that we're going to share a lot of features that people don't use very much. So you'll probably learn something even if you're quite a regular advanced user of the tool. So the examples we've picked are serving a robots.txt file, simple synthetic piece of content that has no backend, just a piece of content generated on the edge and served in response to a specific request. We will also build an example that serves the image of the country in which you make the request, this what we're calling a geolocation flag endpoint. That will give us the opportunity to demonstrate a bunch of Fiddle features like how to do geolocation lookups, how to use IP overrides to simulate a request coming from a particular region, that kind of thing, and how to write tests in Fiddle, which is still like a very underused feature. Then we've got a couple of more advanced examples. We will write an example of a service that when users submit passwords, for example, in an attempt to log into a website, we can actually check whether those passwords are in the Have I Been Pwned open source password leak database. And if they are, we can flag those passwords as compromised. And we'll also do an example of how to use Fiddle to process real-time data. So this is data that is being emitted by a server in chunks, and we can actually process those chunks one by one in real time. It's a lot of stuff, so let's get started.
We'll try and cram it all into 1 hour. Okay, so I'm going to go ahead and start with the very first example, which is the robots.txt one, and I'm just going to give you a summary of that. So there are some new compute techniques that we're going to be using, new to anyone if you haven't used compute before, but I'm not going to go into any detail about those because the focus of today's live stream is the features in Fiddle themselves. So we're going to look at some important features, the number one most important feature, which is creating a new fiddle. So we'll create a fiddle. We'll explore how the errors are highlighted as you type to assist with development. And we'll also look at defining the origins, the requests, and we'll look at understanding the telemetry that is generated by the application to help you debug. So yeah, we'll just get straight into it. I am here at fiddle.fastly.dev. And you can see here that I was working on this a moment ago, but I'm actually going to go and create a new fiddle to show you the entire process. Now you'll see that the fiddle that I was just looking at on the home page had a title, and this is the very first thing I'm going to do. It's really helpful to title your fiddles to identify them within a sea of code. And I'm also going to go ahead and switch it from the default language of VCL, which is Varnish Configuration Language, to Rust, because we want to work with compute today. Now, don't click away if you're unfamiliar with Rust. I know it's scary, but we are going to be showing some JavaScript examples later on, and you may even learn something from this one. So let's take a look at the UI. I know Andrew showed this briefly, but we are going to look at the origin that has been defined here. If you haven't used Fastly before, you need to define origins to be able to send your requests to them, and this is a security precaution. And we have one origin that is defined by default in every fiddle that you create, and that is HTTP me, which is a glitch application. Now, glitch is another online development environment that we're really proud of, but for the purposes of this example, all you need to know is that you can use this endpoint to receive expected HTTP responses. So if you send a request to http me.glitch.me/status equals 200, what you're going to receive in return is a status 200 HTTP response with no body. And this is really helpful when building a fiddle because you may not have a backend to develop from yet. You may just want to experiment with an expected response. So we always default to HTTP me. You can go to this URL in your browser to look at the different options for paths that you can pass to this. But just know for now that this is always going to return a 200. There's also the dependencies section, which is, if you're familiar with Rust, the cargo.toml. If you're familiar with JavaScript, this would be the dependencies section of your package.json. But this allows you to define the dependencies that your fiddle requires. We don't support every dependency that is out there on the market. We've just picked a few that we know really work well with compute, and that's because compute uses WebAssembly and not all packages can compile to Web. If you head to fastly.dev, you can find a page that lists all of the dependencies that are supported in Fiddle and their versions. Right now, we've just got the Fastly crate. This is the only one that we need, and that's because we're going to be doing some basic request response. I'll just quickly run through what this code does here so you're aware. So we get a request that is coming in from a client, and we're going to be returning a response or an error. Now, all this code does at the moment is set a custom header on the request, send it to the backend, and then return the response that we receive from the backend. So let's hit run and see what happens. So you'll see the request here that has been sent to Fastly. Now this is part of the telemetry view of Fiddle. This is one of the most powerful features of the application because it allows you to see exactly what your code is doing internally. Some things you wouldn't normally have visibility into, for example, if you were just looking at this in Chrome DevTools while you're accessing your application. This here is actually all of the internal calls that are being made. So we see the request that's made to Fastly, and this obviously goes to run your Fiddle code. So the first thing that happens is a compute instance is started. Then we see that we have printed a log line, So the logging is printed here as well. Anything printed to standard out or standard error will be printed in Fiddle. And if you're familiar with Fastly's log endpoints, you can also log to these and you'll see the output here also. Then we see the fetch that's being made to HTTP me. So when we're sending this request to origin 0, which is HTTP me, we get visibility into that as well. So this is the request that was made by the client, then decorated with all of the Fastly internal headers that was then passed into your Fiddle app. The Fiddle app forwards it to HTTP me, and we get a response back, which, as expected, is an HTTP 200. Notice also that on the request that we've made, we have the custom header that has been set here in the code. Then we receive the response from Fastly or from your Fiddle, which is just the forwarded response from the backend, so no surprises there. But what we want to do is send some synthetic content when a request is made to robots.txt. So let's first update the path of the request that we're making to match that. And then we're going to start writing some code. So because we don't always want to send the request to the backend, I'm just going to go ahead and remove this part and start writing some logic. And this is going to be logic to match based on the method and path of the incoming request, and then perform some different logic based on which those are. So we're going to go ahead and match for get robots.txt, and in that case we just want to return a string. So we call response from body to construct a response object. We're going to go ahead and just put in a standard robots.txt format. And for any other paths or methods, so whether you post robots.txt or you get a different path, we're going to just forward it straight to the backend. So we'll call OK request.send origin 0. We'll unwrap the result. Again, this is just a Rust semantic, but you don't need to worry about that here. And straight away we see a squiggly line on method. Now this is something you'll be familiar with if you're a programmer. This is indicating that something's wrong, but what's really powerful is that this happens straight away and within our browser. So we know that we need to make a change here, and we know that method is undeclared. So I'm going to go ahead and import that from the Fastly HTTP package. And hopefully once that recompiles, we'll see that everything is okay. And I'm going to go ahead and click run again. Now remember, I updated the path, so what we should expect here is that we get a request. Interesting. I still have the log line. There we go. So we made a request for robots.txt and immediately got the synthetic response that we have defined in the code. And just to confirm, we're going to also request the root endpoint, just to make sure that the request is still passed on to the backend. This is saying that it's invalid. I don't believe that it is. Okay, well, rather than making you wait for that, I'll pass it back to you, Andrew, and perhaps you can go on to the second example.
Okay, that's weird. Sure. All right. So let's talk about geolocation. Geolocation is one of the most common features that people use with Fastly. It's incredibly useful because when you operate, a global edge network, you have requests. When you have a use case that makes use of a global edge network, it's probably because you have traffic from all over the world, and you often want to serve that traffic in ways that makes the most sense to those users in their local regions and the local contexts. So let's explore one of those use cases today. So I'm going to create an endpoint that serves a flag. This will enable me to demonstrate using geolocation in Fiddle and modifying the request that comes from the client to make it compatible with an upstream API. We'll also be looking at image responses and how Fiddle represents those, and writing some tests for the first time. So let's get into that. So I've got my browser here already open on a blank Fiddle. Now, by default, Fiddles are VCL, but let's switch this to Rust. And as Kailan said, we promised you we will be using other languages later on in the stream. So this immediately pre-populates with a minimal compute application in Rust. So let's figure out how we can adapt this to do what we want. So first of all, I am going to define some new origins. The default origin HTTP doesn't give us the behavior we need. So I'm going to use country flags API.netlify.app, which is a little app I found on Netlify that seems to do exactly what I want. Thank you very much to whoever came up with that. And I'm going to request from my service the path /images/flag. And what I need to do here is write some code that translates this /images/flag path into a specific request for a particular flag. So I don't want to do any of this stuff. So let's start by checking the path. So I'm going to do rec.get_path equals /images/flag. Okay, and yeah, if it doesn't match the flag, then it can just go to origin as normal. So that's fine. Now inside of here, let's do the geo lookup. So I'll do if let sum geo equals rec.get client IP address. I can then chain using the and then method and pass that to geo lookup, which is a function we offer as part of our Fastly crate. But I think I have to import it actually. Let me import that separately. Use Fastly geo lookup. Cool. Yeah, great. That looks like that worked. So then when we have that geo information available, we can then modify the path. So I can do rec.setPath. I'll use the format macro to create a concatenated string, which will be /flag, and then the country code.svg, which is the particular path that I need for that Netlify backend. And then I'll be using geo.countrycode, not county, country code, to populate that. That should work, I think. Because I'm a good programmer, I'm also going to add some error handling. So if the geolocation lookup fails for some reason, we should probably return something. So let's return a response. Response from body, and I'll just say something like flag not found. That should be fine, I think. Yeah, okay, let's run that and see what happens. Brilliant. So I sent a request to Fastly for /images/flag. We started our compute application and did a geolocation lookup. That geolocation lookup came back with the country code for Portugal, which is where I am right now. And then we made a fetch to our backend. But the fetch we made to the backend was for /flag/pt.svg because we are asking the backend for the Portugal specific flag. And then we're able to serve that to the end user. And Fiddle, being super helpful, when it sees an image as the response body of a request, instead of trying to display that as text or displaying, some binary representation of it, it just displays the image for you. So that's really super useful. All right, so that worked. That was pretty easy. Let's look at how we can test this behavior. So up here, you can see there's a little tests link under the request. So I can add tests. I can actually add tests to every request that I make. So there's a few things I would like to assert here. The first one is that on the client fetch, that the response is an image. Now there's actually a property for this. So I can do this, client fetch.isImage is true. So that will assert that the content type of the client response is an image MIME type. What else? I can assert that the origin request, the origin fetch. Now, it's not origin fetch, it's origin fetches, and then it's indexed. That's because we might make more than one origin fetch. So when you're testing, the data you're testing against is in an array. So origin fetches 0, i.e. the first origin fetch .rec for the request portion of it should include pt.svg. Oops, great. And what else do I want to test for? I'm sure there was a third test case. Kailan, can you remember which test case I came up with for this?
I'm actually not sure.
Is image is true. Oh, I know. I wanted to check that the Fastly platform did a geolocation lookup. So there's three major bits of data that we expose to the testing framework. One is your client fetch, one is your list of origin fetches, and the final set of data we expose is events, which is the a list of all of the compute events that have happened during the execution of your fiddle. So we can do events.where type equals geo, and then dot count, which is an aggregation that just tells you how many there are in the list, is 1, because we know that the execution of this fiddle should generate 1 geolocation lookup. All right, so let's that's weird. Have not changed the code. All right, I will run it again. And 3 passing tests. Amazing. Now the tests are listed here right underneath the client response, so we can see that all of those have passed. The client fetches an image. The request includes pt.svg, and the number of geolocation events is 1. Now, of course, there's a problem here, which is that these tests pass for me. But if I was to put this fiddle into a list of fiddles that was tested by, say, an automation process, then where that automation process is run from will dictate which flag is actually served to that test runner. And it obviously is unlikely to be the Portugal one. So to address that, we actually have a bunch of options that you can turn on to control the behavior of requests in Fiddle. So for example, by default, we send all requests over HTTP2. You can downgrade that to H1.1 if you want, or even plain HTTP1 without TLS. You can choose to clear cache before the request is issued. You can tell Fiddle to follow redirects, and most importantly, in this case, you can tell Fiddle what IP address you want the request to come from. So let's say we want the request to come from a German IP address, and I shall run this again. And I think I just need to make a small change to the code to nudge it to pile properly. Great. Okay, so we have, as expected, got the German flag. We don't have the test results here, and that's because they are failing. And Fiddle keeps retrying the tests until it gets passes. It won't get passes in this case, so these tests, the test runner is going to time out in a second, and there it is. So it's going to tell us that we actually requested /flag/de, and so it's failing this test. So we can just update this test to be de.svg, and now we have a stable test case of this fiddle, which we could use in an automation process to verify that this code is working. And there we go, we passed all the tests. And that is how we do testing in Fiddle.
Fantastic.
What's next?
What is next? Well, we're going to be looking at the have I been pwned password example. So this one's really exciting. This is something that we have as an example on our developer hub, but we want to show you live coding some of it today just to demonstrate how Fiddle can help with it, because we currently only make this available as a starter kit that you would download to the CLI. But this is something that actually works fully in Fiddle as well. So we'll head over to my screen again and take a look at what we can do. So to start with here, because we have a lot of code to write, I'm going to clone a fiddle that we've already created. So I'm just going to pull up the template that we've made. And you'll see here there's a lot more than we had in the previous examples. We've got 2 origins, we've got some dependencies, and we have a bunch of code. Now I want to start writing code here, but I actually can't, and that's because this is a public example fiddle. We can't just have anyone editing those willy-nilly, so we need to go ahead and clone it first. Well, cloning it is really straightforward, and it leaves you with your very own copy of the fiddle to do whatever you like with. So now this is fully editable. I can go ahead and run it, and it's not going to do much apart from pass the request onto the origin, because we haven't actually called any logic yet. But it's going to be pretty quick for us to go ahead and write some logic, because we've got some helper methods here. So you'll see for each request we call process credential, but nothing actually happens here apart from passing the request on. The very first thing we're going to do is actually check the body of the request to see if there were any passwords sent. So I'm going to take the body and put it into a string. Again, this is just the specifics of Rust. In other languages it would be different, but I just want to show you how this looks in Fiddle. So we're going to match on subfields. We're going to try and see if there is a password, and pass in the delimiter here. And if there is no password or an empty password, we're going to go ahead and set a header on the back end that indicates no credential was included in this request. There we go. But if there was a password, we want to go ahead and figure out if it was included in any data breaches in the past. And the way that we do this is by hashing the password and then sending just a little part of the hash to the pwn passwords API, which will then return us a list of all of the hashes that start with that sequence, allowing us to then check securely whether that password has been breached before. So the first step in that is to go ahead and decode the credential, because it is URL encoded currently, and that is not going to appear in hash at all. So we will decode the string using %decode string, which is a method that we have imported from the %encoding crate. Then we call decode and we unwrap the result. Now we have the plain text credential. We want to go ahead and hash it. So we'll set a variable of hashed credential. We want to indicate to the compiler that this is a string, and we'll call the hash SHA-1 method, which is going to take in the decoded credential, and we're going to also uppercase the hash because this is how they are returned from the pwned passwords API. Now this is just a method we've defined earlier on that will hash the password in a way that we expect. And we will also split this because we only want to send the first half to the pwned passwords. It's not a great idea to send hashes of your customers' passwords to random API. So we will just split the credential that's hashed at a known prefix, which again we have defined further up as 5. This means we're actually going to get the first 4 characters of the hash. Then we're going to construct the request to the backend. The backend in this case is the pwned passwords API, which, as you have seen earlier, it is defined as origin 1. And this is for the range endpoint, which allows us to pass in the left-hand side of the hash. Then we take that path and turn it into a request. This isn't going to send the request at this point, it's just going to construct an object that we can send. So then we can actually get that response from the backend by calling API request.send, and we're going to send it to backend API, which is origin 1. Of course, you could just hard code the string here, but it's good practice to be using constants for these, especially when you convert this from a Fiddle into a full-blown Fastly service, at which point you may have different backend names. So we send that request, and then we want to extract the body from the response. This body is going to be a string in this case, but we also have other methods that would allow you to decode form data or JSON, depending on what your backend returns. And this body is actually just going to be a plain text list of hashes that were found in data breaches that start with this left-hand side of the hash. So the final step for us is to determine if that hash right is contained within the list. That's really straightforward. We just want to determine if API response body contains hash right. If so, the result is that the credential is compromised because it's present in the data breaches. Otherwise, we can say that there is a credential, but it's safe. And the final thing for us to do is set the header on the result. So the request that's being sent to the backend needs to have an indication of the password status. So just like we did earlier when there are no credentials, we're going to set the same header but with this result. Okay, so what's left to do? We have an error here. Let's see what's happening. I've done something wrong. Luckily, Fiddle is indicating that there's an error. Do you have any idea?
Let me have a look.
This is why we should do examples in JavaScript.
Well,
it doesn't complain about this.
We're getting there. I can't see it, unfortunately. Like the window I have access to is really, really small.
Okay.
What's the error?
The error is that we have a mismatched type. So it looks like at some point we've got the wrong type of string. I'm just looking at my reference code right now to see where I've gone wrong. Okay. I think we may have to pull up a working example to demonstrate, unfortunately.
Okay.
Do you have the idea of a working example handy?
I do. Hold on. Oh, I don't.
Apologies for this. I can promise we do know how to write Rust here at Fastly.
Yes.
Anyone in the chat can see what we've done wrong. That would be helpful.
Rust
Yes,
version,
Rust.
right. So it's 5C508848.
Was that 5C?
5 Charlie 508848.
There we go. And we have a working example here. This one's slightly different, but it is going to be doing the same thing. So let's take a look at the different requests that we have defined here. So first of all, we have a request to the origin, which should actually return, in this case, a login page. This one's a bit more of a full example. But the more important one is the post request, where we are including a password. So we'll go ahead and send this. I'm going to assume that the password God has appeared in data breach at least once. So the expectation here is on the second request that is made, we're going to make a fetch to the origin with the header fastly password status compromised credential. And yes, we can see that exactly here. So to demonstrate a successful one, I'm going to type a bunch of gibberish in as the password. First of all, I need to clone the fiddle, of course, as I showed earlier. And I'm going to type in a password that I'm imagining hasn't appeared in a data breach at any point. If it has, then great minds think alike, I guess. And I'll run that one, and I'm going to expect this time that the request to the origin says safe credential. And it sure does. So there we go. That is password protection built into your service using a compute layer in front, which is really powerful. But the important thing here is that we've shown off some Fiddle features. We've shown you how to clone a Fiddle. We've made multiple requests to multiple backends rather than just manipulating the original request sent to a backend. And there's actually one thing that I've missed, but Andrew showed earlier, which is that you can capture log output. So any log output that your application emits will show up in the Fiddle report as well. So with that, I'm going to pass it over to Andrew to go through the final example.
Thanks, Kailan. Okay, in the home straight now, I guess.
Mm-hmm.
Let's talk about real-time stream filtering. Real-time stream filtering is a So we are going to look at a couple of new techniques in relation to just using compute, which is dealing with streams. Dealing with streams is quite a good thing to get into with edge computing because the more you kind of lean on buffering responses, doing something to them, and then re-emitting them, the more you're going to get in trouble when those responses start becoming very large or start becoming very long-lived. So the more you can do with streams, and the more you can just kind of default to using streams for everything, the better your edge compute applications are going to be. And we've got logging on here, but actually Kailan just demonstrated logging in the previous example. Fiddle features, so real-time telemetry, we haven't seen anything that happens in real time yet, or at least updates in real time. So we will see that reflected in the Fiddle UI. And also a very little known Fiddle feature, which is the ability to directly browse a Fiddle as if it's a public website. So let's go back to my Fiddle homepage and get started. So I am actually going to, like Kailan did for the password, I'm going to start from a public Fiddle here. So this is actually something that you can find on our Develop Hub as one of our code examples. So first thing I will do is to clone it so that I can edit it. And let's look at what we've got already. So we've got an origin defined here, which is a Google App Engine application. And the URL that we're going to be requesting of our Fastly service is /flights/stream. And what does the code do? Well, ignoring all of these functions here down here that we're not actually using, all the code that is actually functional right now is just this bit at the top. And all it's doing is taking the client request, sending it to the default origin 0 backend, and then passing the backend response back to the client. Exactly, completely vanilla boilerplate compute service. So this path is what we're going to be requesting from this origin. So if we just run this, we should see the data streaming from that backend. Okay, so there's the backend request and the response. And here you can actually see the data appearing from the backend response through to the client response in real time. So the client response is receiving packets at the same time that Fastly is receiving packets from the backend. And Fiddle is updating the UI here to tell you how many chunks we've received. It's updating how much data has been received and whether the overall response is complete, which it now is. But that was a 30-second HTTP response, which dribbles data to us very, very slowly. Let's look at that response directly. So if I go into a new tab and load that URL, you can see, I get exactly the same thing if I go to the origin directly. And this should be recognizable to anyone who's ever dealt with server-sent events. Server-sent events is a really nice, simple streaming protocol, which is a text-based HTTP response that has a double new line to separate events. And then each event is a series of key value pairs separated by new lines. And the keys are pretty standardized: ID, event, and data is typically a JSON object. Cool. So what do we actually want to do here? Well, this is a stream of flight departure information that you might use to update a flight departures board. And let's imagine that we have a lot of users that we want to send this stream to, but each user needs to receive a slightly different variant on this stream, and they don't need all of the data. They only need the data that applies to them. So instead of having all those users attached directly to the origin server, it would be better if we were able to take one fatter stream from the origin to the edge and then divide it up at the edge into the streams that are suitable for individual users. And if you're able to use that kind of pattern, then you could imagine having a really nice scalable streaming architecture where you could have millions of end users receiving streams from the edge, and a very much smaller number of streams having to come all the way from origin. All right, enough talking. Let's have a look at how to do this. So we've defined in this boilerplate code a function called a stream filter, which takes a stream, which is an instance of the JavaScript Streams API, and it returns another stream. So effectively, it becomes a transform stream that can filter the stream that you pass to it. And it also takes an options object that has a few options here: the delimiter that separates the events in the stream, a parser function that can turn the serialized representation of an event into a structured one, and then a validator that can take a structured event and tell you whether you want that event to be part of your output stream or not. We also down here have a little parser function, which is designed to take the string representation of a server-sent event and turn it into a JavaScript object. So let's get coding. So the existing code here looks pretty good up to this point, because we do want to send the request unmodified to the backend. But then at this point, we need to create a new response. So I'm going to call it filtered stream and make it equal to stream filter of backend response dot body, which is where you actually get access to the body response stream. And then pass in my options object. And here I'm going to define the limiter to be a double new line, parser to be my parse SSE function, and my validator to be a new function I haven't written yet, which is going to be called isValidEvent. And then instead of returning the backend response unmodified, I need to return the filtered stream. Now, the filtered stream is not a response. What we have to return from this function is an instance of a response class. So let's create one and pass into it the filtered stream. This is effectively equivalent to, you could also do like return new response of backend response dot body, which is equivalent to doing return backend response, because backend response is a response object that contains the backend response dot body stream. So instead of doing that, we are constructing a new response that's using filtered stream as the body. Now, if we do that, we also need to provide it with all of the response metadata that we are missing, because we're taking just the stream of the body, but we're not looking at any of the other HTTP metadata like the headers. So headers being the most important thing, let's set that to be a copy of the headers that we're receiving from the backend response. And it's also always useful and good practice to be very intentional about your cache control policy if you modify a response in any way. So in this case, we're modifying a response in a way that is specific to a single user notionally. So let's put a private no store cache control header on it. So that is right. That's right. That's right. I think this is okay. I think I'm just waiting for it to compile. Am I? Yes, I am. Perfect. Okay, cool. So nearly there. Now we've got a filtered stream which we're constructing a response out of. The only thing we don't have is this validator function. So let's define that. So const isValidEvent is going to take a server sent events event and needs to return a Boolean, whether to include that event in the output stream or not. So first of all, some of the events on the stream you can see down here are basically blanks. They're just a data key with no value, and there's no ID key, there's no event key. It's just one data key with no value. That's a ping. That's basically the server trying to keep the response stream alive when it doesn't have any data to send us right now. Now, there's no reason not to include those pings in the output stream as well. So let's say if SSE event.data doesn't exist, then, or is an empty string, then let's return true to say, yeah, just include that. Otherwise, I will create a new variable city, which will be SSE event.data.destination. Now that's going to pick out of the event things like Chicago, Marrakesh, this piece of data here from each of the events that we're seeing. Now I need to know whether that particular city is one that I want to include in the output. Now I've created an array up here of cities that we want to see in the output. So let's, where was I here? So let's do const should emit and set that to cities dot includes city. And I guess I can just return that actually to say whether I want that event in my output. Wait for that to compile and let's run it. So with any luck, I should see a stream that is including only events that match the list of cities that I am interested in. And it may well be that currently the stream is not giving us any updates for locations. Let's have a look what's coming through on the stream at the moment. Marrakesh, Stockholm. Are those in my list? They're not in my list. So I guess it's working. It's a little bit unsatisfying, I guess, that we haven't actually got any that are in my list. Istanbul, is that in my list? No. Let's throw one of the ones that it's currently emitting data about into the list. So let's say Istanbul, let's put that in here. Oops. Istanbul, cool. And wait for it to save, run it again. Incidentally, this is ideally not how you would define a list of data at the edge. You would probably connect to one of our edge state resources like a config store or a KV store so that you can update this data without having to push new code. Great, look, we're seeing response that includes events about Istanbul. And if I look at the original feed, I should be seeing events related to Istanbul and also other places that my Fiddle is filtering out. Excellent. One final thing I'm going to show you about this example is the Fiddle feature to browse a Fiddle in a new tab. So if I click on this, then much like in this tab, I'm directly addressing the origin and I'm seeing the output of this URL directly from the origin. In this tab, I should see the output of making a request to the through the Fastly service without all of the Fiddle UI processing it and representing it in a different way. It takes a moment to stand this up, but hopefully in a second it should show us. There we are. Oh, and it's also outputting Dublin as well. That's probably Dublin is on a list of places that we care about. So so this is our raw stream, and this is the stream after filtering. So anytime you create a Fiddle and you want to actually use the interface that it is producing, feel free to press the browse button. It's really useful for things like OAuth flows, or if you ever need to like fill in a form and submit the data and then do something with like any kind of interactive behavior, basically, because it's not always very useful just to see like the raw HTML or whatever it is of the response rendered as part of the Fiddle report. And that is it, I think. We did it.
That's it. We made it through, yes. Despite both of my examples not going as planned, I think we have been able to show off all of the Fiddle features that we think are the most important. In the robots.txt example, we looked at creating fiddles basically, and showing the responses, making requests. This is the core of Fiddle. In the GeoIP example, we had some images in the telemetry, and we also did some IP overriding and looked at tests, which is, again, a really powerful Fiddle feature. A lot of our customers really like using this. In the pwned passwords example, we had multiple origins, we had multiple requests being made, we cloned a Fiddle, and this is the core of what Fiddle allows developers to do when it comes to taking examples, sharing them, building on top of them. And this is something that Glitch does really well as well. Check out glitch.com if you haven't. And finally, in the streaming example, we checked out streaming and browsable fiddles, which again are really powerful features of the platform. But yeah, that's all that we have time for today. Thank you for sticking with us. Thank you if you made it over from the initial stream link. Again, apologies for any confusion there, but we hope you learned something. We hope you get a chance to check out Fiddle. Head over to fiddle.fastly.dev, give it a try yourself, or head over to justfastly.dev and look at our examples on the Developer Hub, which are all runnable within Fiddle straight away. Andrew, thank you for joining us.
You're very welcome.
And thank you to our viewers for being here today. We hope you enjoyed it. And again, we'll be back for more developer goodness next month. Take care.
Bye.